Let's take a look at this problem. We got f of x is equal to negative 3x squared plus 5x plus 4. Instructions are to graph it, find the x and y intercepts. So we're going to find all this rest of this first, then we'll graph it. Okay, x-intercepts. To find intercepts, you always do it the same way. You plug 0 into the other variable. So if I find the x-intercepts, I'll plug 0 in for y. So I got 0 is equal to negative 3x squared plus 5x plus 4. Now I'm going to use quadratic formula for this. A is whatever's in front of our x squared, which is negative 3. B is whatever's in front of our x, which is 5. And C is our constant term, the number at the end, which is 4. And we got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. It's always a good idea to go through and replace all of your variables with sets of parentheses before you plug in your numbers. Now everywhere I had a b in my formula, I'll plug in 5. Everywhere I had an a in my formula, I'll plug in negative 3. And everywhere I had a c, I'll plug in 4. So we got x is equal to negative 5 plus or minus 5 squared is 25. Negative 4 times negative 3 is 12 times 4 is 48 over negative 6. So it gives us negative 5 plus or minus square root of 73. 8, 9, 10, 3, yeah, 73 all over negative 6. Now, so our x-intercepts would be negative 5 plus square root of 73 over negative 6, comma 0, and negative 5 minus square root of 73 over negative 6, comma 0. There we go. Now our y-intercept. You always plug 0 in for the other variable. So plug 0 in for x. So I'm going to have y is equal to negative 3 times 0 squared plus 5 times 0 plus 4. Or y is equal to 4. So that'd be 0, comma 4. Okay, now our next instruction is to, if it's in general form, convert it to standard. If it's in standard, convert it to general. Okay, so we're going to have f of x equal to negative 3x squared plus 5x plus 4. And I'll bring up my steps for this. Step 1. Factor out the number in front of the x squared from the first two terms. Or step 1. Okay. So we'll factor out a negative 3, and that gives us x squared plus 5 divided by negative 3x, then plus 4. If you're factoring, that means divide out. So that's why I did 5 divided by negative 3. That gives us negative 3 times x squared minus 5/3 x, and then the plus 4 at the end. Step 2, take the number in front of the x, including a sign, multiply it by 1/2, square it, and both add and subtract that number inside the parentheses. So we're going to take the number before x, which is negative 5/3, multiply it times 1/2, and you square it. It's always times 1/2, it's always squared. That gives us negative 5/6 squared, which is 25 over 36. So we'll have f of x equal to negative 3 times x squared minus 5/3 x plus 25 over 36 minus 25 over 36. You not only add it, you subtract it inside the parentheses. Plus 4. Now what we're accomplishing there is we're creating two groups. We're grouping these first three terms together and the last one by itself. Step 3. Factor the first group. So we got f of x equal to negative 3 times x minus 5, 6 squared minus 25 over 36 plus 4. So I factored the first three terms. Now it's pretty easy to factor if you remember this trick. Whatever number's right here, right before you square it, sign included, is always what goes right here. Step 4. Multiply a number out in front by both groups. So we're going to take the negative 3, we'll multiply it times our first group and times our second group. So we got f of x equal to negative 3 times x minus 5, 6 squared minus 3 times negative 25 over 36 plus 4. So that gives us negative 3 times x minus 5, 6 squared. Negative times a negative is positive, and this 3 and this 36 simplify, so that's 25 over 12 plus 4. So then we got negative 3 times x minus 5, 6 squared plus 4 times, this is a mixed number, 4 times 12 is 48 plus 25, 68, 73. Let me double check that. (25) divided by 12 plus 4, math, enter. 73 over 12. Okay, that's correct. And this is our standard form. Now the reason why we put in a standard form, more or less, is to help us identify some different items. Now whatever number's in front of your parentheses right here is your a, so they tell us a is negative 3. It's negative, which means the graph's going to open down. Our h is what's inside the parentheses with the x, and it's opposite sign always, so h is positive 5, 6. And our k is a number at the end, which is 73 over 12. Now our vertex is going to be hk, which would be 5, 6, and 73 over 12. Our axis symmetry will be x equals h, and h was 5, 6, so we got x equals 5, 6. Now our graph opens down, which means it has a max. Specifically, it's an absolute max and relative max. I'll just simply say max. Max is equal to k, which was 73 over 12. Okay, now our domain. Domain is always negative infinity to positive infinity for quadratics. Our range is based upon the y part of the vertex. And our graph opens down, so it's going to negative infinity. So it's going to go from negative infinity to the y part of our vertex, which is 73 over 12. Now it's increasing initially, so that's going to be increasing from negative infinity, and it stops increasing at the x part of our vertex, which is 5, 6. And then it's decreasing. Okay. Now let's find the vertex using the vertex formula. Negative 3x squared negative 3x squared plus 5x plus 4. And then we'll use our vertex formula. Now step 1, identify A and B. A will be whatever's in front of your x squared, which is negative 3. B will be your number at before the x, which is 5. Step 2, plug the values from step 1 into negative b over 2a and simplify. So we're going to have negative 5 over 2 times 3, which gives us, oops, I dropped my negative there. That should be a negative 3. That gives us negative 5 over negative 6, which gives us a positive 5/6. Step 3, we're going to plug that value into our original function and simplify. So we got negative 3 times 5/6 squared plus 5 times 5/6 plus 4 gives us negative 3 times 25 over 36. 5 squared is 25, 6 squared is 36. 5 times 5 is 25, so we've got 25 over 6 plus 4. Now this 3 is going to simplify the 36, and negative I'll just put up on top. So I got negative 25 over 12 plus, if I rewrite this with a new denominator, 12, I'd multiply top and bottom by 2, and that gives me 50, and then plus 4. Which gives us negative 25, negative 25 twelfths plus 50 twelfths is 25 twelfths plus 4. So we got 4 times 12, which is 48, 68, 73 over 12. Now the value from step 2 is our x part of our vertex, and the value from step 3 is a y part of our vertex. And you notice it gives us the same as if we did it in that manner. Okay, let's graph it now. Vertex. What was our vertex? Vertex is 5, 6, 73 twelfths. What in the world is 73 twelfths? Decimal really does help on some of these. 6, little smidge over 6. Okay, so 5, 6, and 6. 3, 4, 5, 6. 5, 6. A little bit over 6 is right there. It's our vertex. I had a professor one time said that people get so caught up on graphing. He liked to think of it as if you're graphing, you're not really graphing, you're sketching. And he said if you're not sure if your point's in the right place, make it a little bit bigger. He called that the Big Dot Theorem. Let's see, what else do I got? Oh, y-intercept is 0, 4. So 0, 3, 4 is right there. Graph must open down based upon how it's looking. Our axis symmetry is x equals 5, 6. So it's going to be a vertical line that goes through the vertex. That's my axis symmetry. And it looks like I need one more, and then I can sketch it. So I'm going to plug in negative 1 to this right here. I'm going to plug that into my original problem. Here's my original problem here. So I got negative 3 times negative 1 squared plus 5 times negative 1 plus 4. Negative 1 squared is 1 times negative 3 is negative 3. 5 times negative 1 is negative 5 plus 4. That's negative 8 plus 4, which is negative 4. So that's the point, negative 1, negative 4. 2, 3, 4. Negative 1, negative 4 is right there. Okay, so now I got those points. So it'd be my graph, and then by symmetry I can flip it across that line, the axis symmetry, and that gives me my right side of my graph. And that'd be our answer for the graph.